Find the derivative of g of x equals 1 plus radical 3 minus x. We want to also find the equation of the tangent line at the point 2 comma 2. All right, so first things first, when you plug in 2 into this equation, right, when we find g of 2, we get 1 plus radical 3 minus 2. Of course, 3 minus 2 is just 1, radical 1. So g of 2 does equal 2, which of course makes sense, right? That's what we're saying. When x is equal to 2, the function value is 2. Okay. Quick sketch of this graph, I guess. We don't need to graph this every time. Okay, but if we graph this guy, it's a square root function, shifted up 1. A lot of things going on with this, right? But we're going to shift this to the right 3 units, up 1, and then flip it around. So our graph is going to look a little something like this, I guess. Okay. So what we want to do is, well, this is sort of what we're doing, right? At this point right here, 2 comma 2. Okay. Not drawing exactly to scale, right? But there's going to be a tangent line, okay, to this point at 2 comma 2. We want to find the equation of this blue line. First thing is we need the slope, right? How do we find the slope? Well, there's only one way that we've learned to find a derivative, right? G prime of x is going to be the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay. So g of x, that's just a function itself, right? G of x plus h, we got to look in here, right? We got to plug in that 3 minus. So instead of putting x here, right, I'm going to put that x plus h, right, minus g of x, which is just a function again, and all of this over h. Okay. I didn't write that down again, right? The limit as h approaches 0. So like I said, if you don't write that down every time, it's fine technically, right? But just of course remember, we're still taking the limit as h approaches 0 at the very end. Now we can go ahead and sort of distribute the negative here. So we'll see that these two cancel out, okay? So we're still taking the limit as h approaches 0. And what do we have? We have this radical 3 minus x minus h, and then minus this radical 3 minus x, all of this still over h. Of course, when we plug in the h now, right, we get 0 over 0, so we still have to do some more stuff. We see radicals in the numerator, so hopefully that tells you, right, well, we're just going to rationalize the numerator here. We'll multiply by 3 minus x minus h plus radical 3 minus x, and do the same thing on the denominator, right? We're rationalizing the numerator here. I'm going to put parentheses around these to make sure that we do this properly. Okay. Now notice what happens here. Okay, limit as x approaches 0. Okay. Now on the denominator, I'm not going to multiply this out. I'm just going to keep that h there. I'm just going to keep that radical 3 minus x minus h, and then plus radical 3 minus x. What happens in the numerator though? Remember, these are called conjugates. Whenever we multiply conjugates together, right, when we FOIL, we know that the outer and the inner terms will cancel out. So all we have to do is multiply the first two terms together. So radical 3 minus x minus h times itself is just 3 minus x minus h. And then radical 3 minus x times radical 3 minus x, once again, is just itself, right? Minus 3 minus x. Okay, anything happen here? Well, 3's do cancel out. That becomes a plus x, so those cancel out. And we're left with a minus h on the numerator. Hey, wait a minute. That h was going to cancel out with that h down here. Okay, remember, I'm not going to say it's a trick, but whenever we're doing this limiting process for the difference quotient, the h will always cancel out, always. Okay, of course, we're still left with a negative 1. So what do we have? We have the limit as h approaches 0, and we have negative 1 on the numerator. And what do we have on the denominator? Well, radical 3 minus x plus h plus radical 3 minus x. Okay. Now, wait a minute. What happens when you plug in h down here? Okay. We don't end up with a 0 denominator. So that's sort of good, right? We're sort of done with the problem. So when I plug in that h equals 0 here, I get negative 1 over, well, I get 3 minus x down here, plus another radical 3 minus x here. Hey, wait a minute. I just get my final answer, right? Negative 1 over 2 radical 3 minus x. Okay? And this is it. This is g prime. Right? This is the equation for my derivative. So, pretty long process, but hopefully we've done this enough times that you remember to rationalize the numerator. Well, find the equation on the tangent line at the point 2, comma 2. So when x is equal to 2, right, pretty much what we want to do is we want to find g prime of 2. Okay, so what happens when we plug the 2 in here? We get negative 1 over 2, and then I'm just going to, 3 minus 2 is just 1, right? We get negative 1/2. So what does that mean? It means at this point, okay, the slope of this tangent line is negative 1/2. And now, well, we still, okay, the question says to write the equation of the line, right? Not just finding the slope, okay? So we do want the equation of that line. It's just one more step, right? We're going to use the point slope formula here. Okay, so y minus 2 equals negative 1/2, x minus 2, okay? Let's see, I'm going to have to write this up here, right? So y minus 2 equals negative 1/2 x plus 1. So I'll add that 2 back over to the other side, and then I'll get my final answer, right? Y equals negative 1/2 x. Looks like we get a plus 3 here as the final answer. So we have the equation for the derivative, and we have the equation for the tangent line at the point 2, comma 2.